Hello students, in this video we will be discussing about characteristics of a sound wave. Students, in the previous video we have studied about different types of waves, and on the basis of oscillation of the particles we have discussed about two types of waves. One, that if the oscillation of the particle is perpendicular to the direction of propagation of wave, then we have considered that those type of wave as transverse waves. And here the next thing we have studied, if the oscillation of the particle is along the direction of the propagation of the wave, then we consider those type of wave as longitudinal waves. And we know that sound is a kind of longitudinal wave. So here we will discuss about the wave formation of sound wave. Now what happens when the oscillate propagates in this way, like this is the direction of propagation of the wave, and the oscillation also of the particle also happens in this direction only. When the molecules come together, when the molecules come closer to each other, then there is a compression of the molecules. That is, more number of molecules come in small volume or a small area. And when the molecules separate, then the area increases, and in this increased area less number of molecule is over there, and again compression happens, and again they move away. And a kind of something like this, suppose we have a source of sound over here. This is source of sound, and due to this source of sound, what happens, suppose this is a air medium, and the molecules what happen, first they come closer to each other. When they come closer to each other, there is a formation of such kind of molecules, like molecules come close to each other. And when the molecules come close to each other, the next moment they will get separated. And when they get separated, what happens, this kind of formation happens, like they are getting separated. Let us consider we have drawn it like it. And then again the next moment they come closer to each other, and then when they come closer to each other, this is the formation. And then alternately again the very next moment they go or they move away from each other. And this moves on, and this goes on until the wave propagates. Here, the reason in which the molecules are coming closer to each other is the reason known as compression. And the reason in which the molecules are moving away from each other is the reason known as rarefaction. Again, compression, and again rarefaction is happening. And in this way, the whole path in which the wave is propagating, the same thing used to happen. There is alternate reason of compression and alternate reason of rarefaction, and again compression, again rarefaction, again compression, and again rarefaction. What happens over here is the number of molecules are increasing in a small region. Here the number of molecules is constant, but the volume is increasing. Therefore here the density of the molecules is less, and in this region the molecules of the density is more. So this is the formation of the compressive and the rarefaction region when we talk about the density of the molecules. And when we talk about like pressure, okay? Pressure, suppose this is the source of sound. What happens if there is increase in the number of molecules per unit volume? Then what happens that more number of molecules will apply the pressure on that region, and when there is compressive region is developed over there, then there will be more pressure. And when there is rarefaction region developed, then there is a region in which less pressure is developed. And again, because of compressive region over here, the pressure will increase, and again because of rarefaction region over here, the pressure will decrease. And in similar way, the wave, the wave energy moves and it propagates. This is on the basis of pressure created on the molecules due to the source of the sound. And here when we draw the graph of it. Suppose this line shows the pressure or density of the molecules. The first region we have considered compressive region over here. This is compressive, this is rarefaction, this is compressive, this is rarefaction, and so on. Alternately, we are having both the things. Now here, the compressive region is shown as the maximum part above the mean distance, and the rarefaction region is defined as or shown as a lower part. And then again the maximum part, and again the rarefaction came, the lower part, and again there will be a maximum part. And similarly we get a structure, and this structure is known as the wave structure that we have studied in the previous chapter. Here, this part we have studied the above the mean path, above the mean average line, we have considered this maximum distance as crest, and this is known as trough. And we have also studied that between the two, the distance between the two, crest, suppose this and this, a distance between the two trough, a distance between two places from where the wave is starting, this and this. Okay? From here the wave is starting, and here also, the distance between the two consecutive waves of on the same phase is known as wavelength. And here the wavelength will be from, it is starting from compression and it is ending to rarefaction, and from here the compressive region starts. So this is the wavelength of this this sound wave. So we have created it in the form of wave, and this is how a sound wave is formed. Clear? Now we have studied two reasons. One is compressive, one is rarefaction. Let us understand that. Let us write it first. Compression is the region with high density, and high pressure. With high density and high pressure. Sorry, it is pressure. Okay. And when we talk about a rarefaction region, it is a region in which the density of the molecule is less or the pressure is low. This is region with low density and low pressure. So this is how we discuss, or how we make a wave in a longitudinal wave. So sound is a kind of longitudinal wave, and this is the structure how it is formed. Though students have the confusion that if the particle is oscillating like this and this, up and down from the mean position, the formation of wave happens. But how the formation of wave happens in a longitudinal wave? So this is the process how the wave formed in a longitudinal wave. So from here we will discuss. So we already know this is the maximum displacement, and this is also the maximum displacement. Both is same for the same, for same wave, for one wave, all the maximum displacement above the line, the maximum displacement below the line is same, and this is known as amplitude. We know about it. This is known as amplitude, and in 1 second how many cycles are completed is known as the frequency of that wave. We have already discussed it about the previous video. You can watch it in the YouTube channel over here. So from here we will move to understand about pitch, and we will study about soft sound and loud sound as well. Now suppose students, we have two waves. Okay? Two sound waves. Let us consider two sound waves, and in both the sound waves, in this vertical line shows the wave disturbance. Let us consider this is showing what? This is showing the wave disturbance direction in which the wave has been disturbed. Wave disturbance of both the sounds. Two type of sounds. In one type of sound, we got to know that the wave formation, let us consider the wave formation is something like this. And in the second type of sound, we see that let us consider this is the wave formation. Let us consider this is the wave formation. Two things we are discussing, we have to understand first. The amplitude of both the waves are same. Let us consider the amplitude of both the waves are same. Here A1, let us consider this is A1 and this is A2. Here A1, the amplitude of the first wave is equal to amplitude of the second wave. But here in 1 second, let us consider the frequency here is 1 Hz only, and here in 1 second, this is actually the time axis. This is actually the time axis. In 1 second, the wave is completing 1 cycle, and here in 1 second, the wave is completing 2 cycles. Here the frequency, this is, let us consider the frequency here is mu1, and let us consider it is mu2. Here the mu1, the frequency created by sound wave 1 is less than frequency of sound wave 2. So we say that since the frequency over here is less and frequency over here is more, we consider this to be as low pitched wave, and here it is a high pitched wave. Clear? So here this is a low pitched wave and this is a high pitched wave. What is the difference? First, let us see the similarity. Similarity is in both the waves the amplitude is same, but the difference is the frequency of this wave is less than the frequency of this wave. So more the frequency, more is the pitch, less the frequency, less is the pitch. Now let us discuss about loud sound and soft sound. Suppose again, let us consider we have two types of waves, two types of sound waves. Let us consider this is the first one and this is the second one. Here, let us consider in the first wave, this is the amplitude. Only this is the amplitude. And here, let us consider this is the maximum displacement. And here, what we know, this is amplitude. Let us consider this amplitude of the first wave is A1 and amplitude of the second wave, let us consider it is A2. This is the time axis, obviously. This is the time axis. Here we have considered the frequency of both the waves are same. And the one thing which is different in both the waves is that the amplitude of wave 1 is less than amplitude of wave 2. So more the amplitude, louder will be the sound. So here in this case the sound is louder and in this case the sound is softer. So we have studied two things. One is loud sound and the soft sound, and other is low pitch and the high pitch. Here we have considered amplitude of both the waves are same, and here we have considered the amplitude of both the waves are different. Here the frequency of both the waves are different, and here the frequency of both the waves are same. In this way we have studied two things. One is low and high pitch waves, the other thing is softer sound and the louder sound. Now students, we will be discussing about quality of sound. Now quality of sound help us to distinguish between two type of waves. One, if we have two sounds, suppose we have two sounds, okay? Suppose we have two sounds, so if we know the quality, from quality of the wave, we will consider two waves having same pitch. We have studied same pitch about louder and the softer, whether the sound is louder, whether the sound is softer. And the other thing that we have discussed is one which is loudness. So we have discussed about two qualities. One is about pitch and the other is about loudness of the sound. Here, if the quality is rich, if the sound quality is rich, then we call it as a pleasant sound. Pleasant sound. What is pleasant sound? Suppose if you are listening to any music, and it is pleasing you, you are interestingly listening to that song, then that kind of sound is known as pleasant sound. And what is unpleasant sound? Unpleasant sound, obviously you might have studied, if the sound is not, it is irritating kind of thing, then we call it as unpleasant sound. For example, noise. Clear? Now, students, there is one more thing. The intensity of sound, and the other thing is loudness of sound. Students used to confuse in both the terms. Sometimes both these things are used, corresponding to each other, but they are different. How they are different? This intensity is the amount of sound energy. This is nothing other than amount of, this is amount of sound energy which is being propagated from any unit area. And this is nothing other than the measurement of response of our ear. Measure of response of our ear. Like, if someone is standing in front of me, he might consider sound is louder. If someone is standing away from me, he might consider that the sound is, softer. So both the things are different, intensity of sound and loudness of sound. Here we are studying about amount of sound energy, and here we discuss about the measurement of the, loudness of, it is just a response, how our ear is responding with respect to the sound which is being provided. That's it with the characteristics of the sound wave. Thank you very much for watching the video.